Welcome everybody, and thank you for joining us today to today's webinar on solar district heating, new developments, and a proven success story. We will first watch a recording of the presentations that were given in the initial webinar on Monday. And after the presentations, we will be joined by the speakers for a live Q&A session, which today will be moderated by Christoph Brunner. So while you're watching the recording of the different presentations, you can already submit your questions in the Q&A chat box, and then they will be answered once the speakers are live. However, please note that unfortunately, one of our speakers, Lucio Mesquita, is unable to join today's session. All right, so for now, I'm going to leave you with the recording of the presentations, and we will speak again in a bit. There. Welcome everyone, and thank you for joining us today on today's webinar on solar district heating, new developments, and a proven success story. This webinar is part of the lead up to EuroSun 2026 and to SolarPACES, and we're excited to give you a quick first look at how the two conferences will collaborate. My name is Ellen. I'm a representative of ISIS, the International Solar Energy Society. We are today's technical host, and I will start by giving you an overview of how today's session is structured, followed by a brief introduction to ISIS and to EuroSun 2026. So we begin today with short opening presentations. Mine is followed by an overview of the IEA SHC activities by its chair of the Technical Collaboration Program, Lucio Mesquita. After that, we will have a brief overview on SolarPACES by its conference chairman, Robert Pitts-Powell. After this, we move on to our technical presentations by Magdalena Berberich and the other one by Joachim Bieström. After that, we will have a live Q&A session, which today is moderated by Bärbel Epp. Regarding the Q&A session, please feel free to submit your questions in the Q&A chat box at any time. Please write who your question is directed to, and we will then answer your questions at the end during the session itself. Now, regarding ISIS and EuroSun 2026, first of all, what is ISIS? ISIS is a UN accredited membership NGO. We were founded in the 1950s, have been UN accredited since 1992. Nowadays, we have a diverse international membership with members from over 110 countries. And our mission statement is 100% renewable energy for all, used efficiently and wisely. To achieve this mission, we have multiple activities going on, including 2 major publications, webinars, education initiatives, infographics, an online solar energy museum, and most importantly, we organize 2 major biannual conferences, one of which is the EuroSun. So a bit of background on the EuroSun conference series. The first EuroSun was held in 1996 in Freiburg and Breisgau, Germany. And ever since then, it has been held all over Europe every 2 years. This year marks the 30th anniversary of the EuroSun conference series. And because of this anniversary, this year's EuroSun will again be held in Freiburg from September 14th to 18th. Apart from that, we also celebrate 2 other important birthdays this year. For one, we are celebrating 70 years of ISIS and 50 years of the IEA SHC program. So as I just mentioned, the EuroSun will take place in Freiburg this year. Freiburg is a city located in the southwest of Germany. It's very close to France and Switzerland. It's known as Germany's Green City due to it being a hub for solar energy research, sustainability, and innovation. But Freiburg is also known as a very popular tourist destination due to its very beautiful old town and due to its black forest surroundings. The venue of this year's EuroSun is the University of Freiburg, specifically the university's campus, which is a historic campus with over 500 years of academic tradition. The main conference building this year is the Kollegiengebäude 1, which you can see at the bottom left. It's a protected heritage building which combines classic architecture with modern facilities, as you can see in the other 2 pictures at the bottom. We're excited to announce that it is now possible to register for EuroSun 2026. The portal is open. So we invite you to visit our website, eurosun.conference.org, to secure your place. This year, some of our program highlights include keynote speakers from research, industry, and policy, We're also offering a master's course in solar energy as well as technical tours. And something that we're very excited about is that this year, for the first time, EuroSun and the SolarPACES conference series have decided to collaborate. So this year, EuroSun 2026 and SolarPACES will run in parallel. They will both run in Germany, and we are now working on building several bridges between these two events. For one, a thing that we're going to offer is a mutual acceptance of conference tickets. So you can buy a ticket for one event, but then also attend the other one. The specific details on that will follow soon. On September 15th, additionally, we will live stream selected presentations across both venues. And ultimately, to top it all off, we will finish this collaboration with a so-called post-conference highlights webinar. And overall, this collaboration is designed to make it easier to engage across both communities and to keep the solar energy research community strong and united. So in short, come to SolarPACES, come to EuroSun. And with that, thank you again for joining us today. And I'm pleased to hand over to our next speaker, Lucio Mesquita.
Thank you very much, Alan. Now, quickly share my screen. All right, I'm just going to do a very quick introduction to the solar heating and cooling program, our technology collaboration program. First of all, the IEA technology collaboration program has been around for a little bit over 50 years right now. And it's a unique global network to support cutting-edge research and dissemination in terms of energy technologies. I believe there are now around 38 TCPs covering all different areas of the energy sector. Solar heating and cooling TCP is one of the oldest ones. Our agreement was signed in 1976, so we're coming to our 50th anniversary. And support the development of not only solar heating and cooling, but also related technologies, and I'll talk a little bit more about that in our next slide. Our work is collaborative, so we do not fund any research directly. The work is done in collaboration, so with participants contribute their time and resource to achieve our common goals. Not only we collaborate within our TCP, but also with other TCPs, including joint projects or tasks, or depending on how you call it. This includes work with SolarPACES, for example, PVPS, EBC, which is the buildings TCP, heat pumps, energy storage, hydrogen. So collaboration is the keyword here. In terms of areas of work, of course, as the name implies, we work on solar thermal heating and cooling, but also PV-driven heating and cooling, photovoltaics heating and cooling, passive solar building, solar architecture, that also includes daylighting and thermal comfort, solar communities, photoreactors, and other complementary technologies such as thermal storage and heat pumps, when you're collaborating and working on systems that have all those technologies together, and sectors, residential, commercial, and industrial. Well, we have two main activities. One is working on the research and innovation side, and of course on the dissemination, which is basically what we're doing here today. Most of our work is done through three main parties: the executive committee, then we have the tasks. Tasks are projects. Usually they run for 3 to 4 years, and any member of SHC can propose a new task. So we have a few tasks running, and we are, I believe, at task 75. We have had 75 projects in those 50 years. But we also have a new initiative. It's called the collaboration groups. So collaboration groups are a bit different. They're meant to be permanent with a broader and high-level scope than what the tasks do. And we have 5 collaboration groups so far: solar water heating, solar cooling, solar neighborhoods, solar heat for industrial process, and solar district heating. On the dissemination side, as I mentioned, it's a lot of work that we do in that regard. And actually, We have what we call the Solar Academy. The webinars like this one are part of our Solar Academy. We also do on-site training, separate workshops and seminars, EuroSun conference, as Alan just mentioned. So this is a joint initiative we have with ISIS. Technical reports, papers, and books. So there's an amazing amount of information that is published through those, including, as we see on the screen there, the Solar Heat Worldwide, which is our flagship publication that covers the solar heating market all over the world. And then we also have a newsletter and, of course, a website with social media. Just to close, stay tuned. We have some big and exciting changes coming this summer. If you would like to know more about SHC, or even better, if you would like to join our activities, please check our website or reach out to our secretariat. That's the contact information there. And last, I just want to thank ISIS and SolarPACES for joining us in this Solar Academy webinar. It's great to have here with us today Dr. Hubert Pitts-Paul. He's not only SolarPACES chair, but also an accomplished researcher and director of the German Aerospace Center, DLR. And of course, a big thanks to our fantastic panel with Babo from Sorico, Magdalena from Solitis, and Joaquin from Absolicon, who have all contributed greatly to our TCP activities. So this is just one more. I hope you all enjoy the presentations and discussions, and thanks for joining this webinar. Thank you. Back to you, Ellen.
Ellen, should I take over? Well, our next speaker...
Or we can go to Robert, yeah.
Yeah, the next speaker will be Dr. Robert Pitts-Paul. I think he was already well introduced. I'm really happy to have you here. You are chairing the SolarPACES conference, and you will give us some details about this interesting event.
Okay, thank you very much. And I also try to share my screen. Together with my colleague Benedikt Kölsch, I have actually the pleasure to host, to chair this year's conference, the SolarPACES conference taking place in Bad Neuenahr, and it's actually the 32nd edition of this conference. And before I go into some of the details, please make me sure that you're all aware about concentrating solar technology. So this is a very brief animation video that shows you the principle. When you concentrate sunlight, in this case on a parabolic trough collector, you are able to achieve very high temperatures, in this case like 400 degrees centigrade. This energy can be used, for example, to generate steam, and this steam can then be used on the one hand side for process heat application, but also as shown in this video here for the generation of electricity. This is actually a large scale application, so you typically do it in many megawatts. And one nice thing is also the energy can be stored as thermal energy very effectively and easily, typically in a molten salt, and can then be used to continue the operation during nighttime or during periods with no clouds. So just to make sure we are all talking about the same topic and you are aware, SolarPACES is the implementing agreement, the technology collaboration program that is actually working on this kind of technology. So our vision is, of course, linked to this on concentrating solar technology. We want that this becomes an option to significantly deliver clean, sustainable energy worldwide. And as an international association, our mission is to facilitate the technology development, the market deployment, and energy partnerships by providing leadership as an international network of independent experts. So those of you who are not familiar, this is a technology typically suited in Sunbelt countries, and this is somehow reflected also in our membership situation. We have 18 members, many of them also from the Sunbelt, as you can see here from this slide, but also, of course, technical nations that are providing the development of the technology, as you see from this map. Interestingly, the technology has been ramped up in several phases in different areas around the world, and you see somehow the distribution overall today, 8.5 gigawatt operational about 4 gigawatt under construction, and we can say right now China is a big hotspot for the technology, in particular for electricity generation, but we also see current activities in other countries, like, for example, in Mexico. The other aspect that is becoming increasingly interesting and also with respect to the market is the field of solar industrial process heat. And you can see from this figure here that the concentrating technologies actually also gain a lot of interest and a lot of share in technologies with this kind of technology like parabolic troughs. So what is actually SolarPACES can do in order to promote this? Of course, one aspect is similar to also solar heating and cooling. We do coordinating research. The other important aspect is international conferences, and the SolarPACES International Conference is the premier conference in the world on this particular topic, running for many, many years. Other important aspects are the development of guidelines as a basis for standards and other aspects in order to make this technology also, let's say, clearly defined and reliable. And of course, we are providing not only information to the technical community, but also to the policymakers. Just as I mentioned, the example of Mexico, where there was an interest in the technology, and SolarPACES is actually able to leverage and to help in this kind of endeavor based on the experience of many, many other projects in other parts of the world. We are also collaborating in times of tasks. On the other hand, task is used a little bit different compared to solar heating and cooling. Tasks are, in our case, more like topics. And among these tasks, there are particular projects or activities. Some of the activities are also funded inside of SolarPACES, so the little seed money that we can start activities. And you see in this slide here, we have different kind of activities in the field of solar electric systems, in the field of solar chemistry, in the field of technology development, in the field of solar industrial process heat, and also in the field of solar resource assessment. Many of these activities, as mentioned before, are also in collaboration with other IEA technology collaboration programs, like, for example, solar heating and cooling. Typically, we have task meetings also together with our joint aside of our SolarPACES conference in this year, scheduled many of them on September 14th. And if you have interest to join one or the other activities, please send us an email in order to receive an invitation to the different activities. So now let's come to the conference very briefly. It will take place this year in Bad Neuenahr in Germany. It's a very nice little village in the Ahr Valley, the most northern Rhine wine area in Germany, a very picturesque site. And we have a fantastic conference site here, a fully renovated conference location. You may know that this valley has been suffering about a flood that took place in the year 2021. Many of the activities have to be rebuilt, and the fortunate thing is that right now we have everything very nicely renovated and available for the conference. So let me talk briefly about the contents. One important thing of this SolarPACES conference always has been that we have one day with a lot of plenary sessions that give a wide overview of presentations. One is joint activities, as already mentioned, broadcasted between Freiburg and Bad Neuenahr on two topics, thermal energy storage and solar heat for industrial processes. We also have a joint session on CSP around the world, or the new activities around the world. We will have a session on bankability and financing of this project, and also one plenary overview on solar fuels and high temperature applications. As you can see from our abstract submission, we have a scientific program that covers about 330 submissions. Many of them may also be relevant for people from Freiburg, so there's a lot of relevance maybe to consider also this kind of double ticket. So thermal energy storage, solar industrial process heat, and solar collectors are just shown as one of the examples. So, and with this, I just wanted to conclude. Thank you very much for your attention. If you want to know more, visit our website, also the conference website. And as mentioned before, the conference is now open for registration. So I hope I can see many of you later this year in Bad Neuenahr. Thank you very much.
Thank you, Robert. Interesting. I think what really profits the two conferences is this large network of researchers that you have built up both in solar heating and cooling and in solar concentrating. And a lot of these researchers provide interesting content during the conferences. So this was the two introduction presentations. Now we come to the technical part. We have two really dedicated experts in the field of solar district heating with us. First, I want to like to introduce Magdalena Berberich. She is co-director of the German Institute SolarPACES, where she's working since 2015. Her expertise includes research and consulting for large-scale solar thermal systems, developing and optimizing seasonal and multifunctional heat storages. And she was also subtask leader within one of the IEA SHC tasks. It was number 68 on efficient solar district heating. So Magdalena, it's your turn. I'm looking forward to your presentation. You are still muted.
Yes.
Yeah.
Hello.
Perfect.
Thank you for the invitation and the introduction. So you can see my slides now, I guess.
Yes.
Okay. So SolarPACES is a research and consulting company from Germany. We are in Stuttgart, and we are mainly active in the field of large-scale solar district heating and large-scale heat storages. And yes, like Bärbel introduced already, my field of expertise. Today, I want to speak about solar district heating and how can solar thermal help to complete decarbonizing district heating. We have the situation that we have around 16,000 district heating networks in Europe, and with almost 500 terawatt hours of heat supply. So it's an enormous task to decarbonize this heat and to supply it with renewable and emission-free heat. Now the share of renewables and waste heat in 2024 was 46% already. And of course, we need to go further here. And solar heat can be one part of the solution. It's one of the proven technologies. It's available everywhere, cost effective and emission free. And so we are very convinced that it can play an active role here in the decarbonization of district heating. And the good news is around Europe, there are a lot of towns and cities already using solar district heating. Here, for example, in Denmark, there's a large share of solar district heating. In the Netherlands, in Germany, and in Austria. These are the markets with the highest numbers of plants or installed capacity. And and there are newcomers. There are other countries also installing new plants. So there's a lot of development here. We take a deeper look into Germany. There we also have a lot of installed plants, now 241,000 square meters and 159 megawatts installed in 71 systems. These are numbers from end of 2025, so there may be some changes now. In 2025, we had 10 new systems. There's yes, good development, especially last year. There were a lot of square meters new installed. And we know from the market that there are ongoing realizations. So plants that are in the planning phase, very concrete planning phase, so that they will be commissioned or will be installed in the next month or years. And here it's also 10 systems with 132,000 square meters. So we know that the plants gets bigger, so there are more collector area, more higher share or higher square meters are installed per plant, and the plants are very different. So we have like bioenergy villages, we have plants in towns, in the district heating networks of cities. And so we have very different structures in the installed plants. For example, here in the south of Germany, near Stuttgart, there is one plant in Tübingen, which went into operation last year. And here you can see on the left side in the photo, it's from the inner part of the heat storage, a steel tank storage, and on the right side, the collector field in the construction phase. And it was a special thing with this plant that it was installed on a drinking water protection area. In the beginning, everybody said it's not possible, but then it was possible with a lot of communication with the local authorities to convince them that it's not harmful to the drinking water, that it's okay to install the plant. And in the end, it was possible. Next step in size, we have now the largest solar district heating plant in Germany is now in Leipzig. It's this week, it will go into operation. It's 65,000 square meters of the collector field, and it's just 2% of the solar share of the district heating, because the district heating of the city, you can see it in the background, the city area, the district heating is a very large one. And so the collector field can supply 2% of it. And this is very important to know that, of course, solar thermal can be one part of the solution, and together with other renewable energies and with other technologies. So it's already, it's everywhere important to take the location-based decisions and not to say it's one system everywhere. This will not be possible. But we need to see the whole system, to see that solar thermal is one part, that there are other technologies which needs to be considered, that a whole system is responsible for the heat supply and not only one technology. And storages, thermal energy storages are also very important part of the systems to manage the heat supply and the different technologies. Coming to the market and what is necessary to decarbonize district heating in Germany. Here it's a forecast of how the heat demand will develop in the next years until 2045, until climate neutral Germany is decided for 2045. So district heating is expanding, that is expected, and the heat demand overall will increase by 50%. And here for solar thermal, there's a calculation, a scenario that 4 terawatt hours per year are can be part of the heat supply, can be part of the solution. And this would mean that we need 10 million square meters of collector area in total to supply these 4 terawatt hours per year. Now, you saw it before, we have 241,000 square meters of collector area installed. So there's a lot to do. There's a lot to do in the market to prepare the share of solar heat in decarbonized Germany in 2045. And we learned in the last years a lot about what can help and what can maybe not help. So here, lessons learned from policy. This is the development of solar district heating plants in Germany. And we saw that here in 2020, 2021, there was a new funding scheme. It was planned, and then it needs more time to be started than it was expected. So 2 years, the market waited for a new funding scheme, and that was And we saw that in this time, the installed capacity didn't increase very fast, but in the next year, all the plants waiting for the installment were installed, so that in 2022, the capacity goes up. And the next part in 2023, there's also a problem with the building permits. It takes long time. It took long time in 2023 and still takes long time to get building permits, of course, depending on the local situations. And this can also, be part of that it takes long to install plants and that the market can increase. So this is very important to consider on the policy side to not hinder the market on new installments. Of course, the 10 million square meters need a lot of area, so it's important to find areas and to find it near the heat demand. So it's important to know that areas where solar thermal is installed can help to protect the environment, because the solar thermal plant can be an ecological upgrade in comparison to agricultural area or to just green land. Here, the biodiversity increases. Over the years, the solar thermal plant is installed, and some of the plants, especially in Denmark, they also have sheep who are on the area. So also this is a possibility. A short summary of what are success factors from our point of view in Germany. The local heat planning is one important part. It's mandatory in Germany since 2023. So it's important for the communities to define which areas will be district heating and which are in the city for single house solutions. And also the National Building Act, or National Law Building Energy Act. It means that new systems, heating systems in houses, need to reach a certain amount of renewable energy, or they need to be connected to district heating. And district heating systems have to make a transformation plan for total decarbonization until 2045. The first part is currently in discussion to update it. And there are subsidy programs like BEW, and there's funding for investment and for operation. And in some, it's possible to reach 50% of the investment. And the funding is for different technologies. So it's not only solar thermal, but also heat pumps, for example. R&D activities are important to push the development and the market, and best practice, of course, where people can see how it works in other places, and know-how transfer like today. So I look on the time, maybe just 1 minute more. I want to tell you also that we were active in IEA SHC Task 68, where we where the topic was large-scale solar district heating, and in different technology combinations and in different sub-activities. And results were, for example, a technology position paper where everything is summarized from the results. There are a lot of technical reports. There are webinars and videos, so you can have a look, and I'm sure it's some new for you included, where you can learn something about the technology and the systems. New that within IEA SHC are the collaboration groups, Lucio told already, and I just want to add that we have a joint meeting at EuroSun. There will be a session to introduce the collaboration groups. So I'm very looking forward to see some of you there. And the registration for the collaboration groups will be available soon as well. So if you're interested, I'm happy to see your registration.
Perfect,
So thank you.
Magdalena. Yeah, thank you very much. A good view into the dynamic solar district heating market in Germany. Very well done. And also a lot of networking opportunities during the conferences. So our second and last speaker will be Joachim Byström. He is CEO and founder of Absolicon Solar Collector, a stock-listed Swedish company. So he has a different view on the European market. The company is specialized on a glazed concentrating collector parabolic draft, and he was working in solar thermal technologies for more than 2 decades. So an interesting speaker from background industry. Joachim, the floor is yours.
Yes, thank you. Joachim Byström from Absolicon and Savo Solar. But I just want to start with this huge challenge that we have in front of us, that is to transfer the heat. That the electricity is only 20%, transport is 30%, and heat is 50% of the total energy consumption. And this is because heat is needed in all industrial processes and in district heating and in houses. And to make this heat, we burn fossil fuel. And now we need to cut the fossil fuel by half every decade. But at the same time, we are going from being 8.3 billion people and 1 billion middle-class people to be 10 billion people and 4 billion middle-class people on Earth. So the global economy will grow 4 times by 2050. So at the same time as we need to cut down on the burning of fossil fuel, the energy consumption will continue to increase. And we get this huge gap between the way we got the energy before and the energy that we need for the future, that need to be filled by renewable energy. And something with a little nuclear, but it will be just a small piece of this. So this is a huge challenge for all of us that work with energy, and especially working with heat. And I think that this with storing heat from summer to winter is one of the keys, that using solar thermal, like here in Dronninglund, collect it with solar collectors and store it in, for example, pit storage or borehole storage to winter. And here you can see how simple it is. You have the solar collectors, you dig a big hole, you put a liner inside, you fill it up with hot water in summer, and you can use the hot water all year round. And unfortunately, this technology has been under the radar, I would say. The EU Commission and other European bodies have not taken much notice to this technology. But now when we have this crisis in the Hormuzsund, then the 22nd of April, the Commission published a number of actions. And one of those actions was actually to help develop public support schemes for the large-scale solar thermal projects, and to see that solar thermal becomes one of the pillars here in the transition away from fossil fuel and to a more resilient Europe. And Absolicon, our part in this is working with large field. And there has been another also Scandinavian or Nordic company working with large-scale installations, Savo Solar. Absolicon, we work with solar concentrators, and Savo Solar with flat plate collectors. We work more with industries, and Savo Solar work more with solar district heating. And we have now decided to join hands. We have bought Savo Solar, and we will work together as one company. And we do solar concentrators that you can see on the left side, producing up to 160 degrees, while Savo Solar manufacture this fantastic large-scale solar thermal flat plate collector. The production has stopped now, but we own all the patents to restart the production. But we will also cooperate with other manufacturers of large flat plate collectors. So there are two very different principles. The Absolicon concentrator, it's 5.5 meters long, 1 meter wide, and it focuses the light like a magnifying glass to produce high temperatures. And we have the world's highest optical efficiency for a small parabolic trough with over 76%. While the Savo Solar collector is a traditional flat plate collector where the sun shines on the flat plate, but maybe not so traditional, because Savo Solar had the idea of making a solid aluminum with channel inside that gave them the highest efficiency for a flat plate, non-evacuated. So Absolicon and Savo Solar, we have been in the solar district market. These are examples of installations that Savo Solar has built in Europe, but there are over 20 of them. And those large installations, they work exactly as we heard, providing heat for the cities. And Savo Solar's installations, they work best at temperatures up to 80 degrees. But Absolicon also have built a few district heated connected installations, like this one on Högslätten in Sweden. And here we produce up to 110 degrees Celsius. It's very easy to get high temperatures with the concentrators. And those two technologies can actually be combined. So you can have flat panels to take in the cold side in the district heating network and heat it up like from 50 to 70 with a flat plate, where they are very, very efficient. But when you get above 70 degrees, the flat plates loses some of their efficiency. And then you can instead run the hot water to a field of solar concentrators and push up the temperature further. And if you, like in Germany, often have quite high temperatures in the district heating networks, you can add more concentrators and push up the temperature even higher, up to 160 degrees if you would like to, which might be suitable if you want to store the heat in a pressurized hot water storage. Now, a few words about the Swedish solar district heating. As I said in the beginning, people think that the world is run on electricity, but in reality, every little city in Sweden have a small district heating network. The red dots here are fired with biofuel, the orange one burn waste, and then we have some that burn peat, the yellow one, and some connected to residue heat from industries. And those burning waste has been like the main way for a bigger city. But recently we had a new law about recycling. So all the buildings in Sweden need to have a real recycling system of trash with 8 different fractions. And this has reduced the amount of fuel for the waste incarnation systems to 25% of what it was previously. So now we are importing a lot of waste from, for example, Italy to run our waste incarnation plants. So I think this idea that we would burn waste, it's actually something that will pass, because we will recycle both paper and plastic, and then it's nothing to burn. And we do biogas of the food waste. And the district heating system in Sweden, it's huge. We do about 138 terawatt hours of electricity and about 50 terawatt hour of district heating. So it's really strange that no one talks about the district heating system in Sweden. And the typical district heating system in Sweden, for a small town like my hometown here in Härnösand, it has many different energy sources. It has a wood chip boiler with a turbine for electricity generation. It uses waste heat from a local pellet factory. It has a pellet boiler for summer operation and peak load. It also has a 20 megawatt electric boiler, and they have small boilers on oil out in the network for backup. And the cheapest heat is produced when the large wood chip boiler is used. And that is in winter. But in summer, the heat load is not sufficient to operate the big wood chip boilers. Instead, they run the smaller pellet boiler. And that means that the heat is about double as expensive in summer as in winter. And this is the case in many of the biofuel powered district heating networks around in Europe, that the heat is most expensive in summer. So a very logical thing to do when you do cost reduction is to stop burning in summer and use solar heat in summer, and then you can burn wood chip in winter. But this message is really tricky. When we come to people and talk about solar thermal, they immediately think, oh yes, we want solar thermal in winter. That's the normal reaction. And then, no, you should use solar thermal in summer when the heat is as most expensive from your plant. And I think slowly we are getting people to pick up on that one. We are super interested in those pit storages, and we have done a real mapping of Sweden with where we could build pit storages based on soil depth, soil type, elevation data, and district heating areas. So for every Swedish city, we have done this kind of area maps where we mark up in yellow the areas where they're suitable to build solar thermal and pit storages. And what we found was that about half of all the Swedish district heating networks, 200 Swedish cities, have good conditions for solar thermal and pit storage based on soil conditions, available land, and sufficient heat load. And for example, as you feasibility study here in Härnösand, the bluish areas here is where there is good conditions for a pit storage. And then we connect it to the grid, of course. And in Sweden, in Härnösand, you see, we have different energy sources. And we propose then a system with solar thermal and a pit storage combined with a heat pump to empty the storage fully. And here we need to put the heat on the return forward, as we have flue gas condensations. We cannot just put it into the return line. And the result is that we get this kind of combination of different energy sources. And based on what discount rate you have, what interest you pay to the bank, and how long time you expect the operation to be going, you get different levelized cost of heat. So you see, with like 3% discount rate and 30-year, you get about 58 euro per megawatt hour. But this is with today's price and without any subsidy. So I think there's a lot of price reduction to win here. And that, I think, is one of the key questions, how to make solar thermal even more profitable for the end users. And of course, more installations, larger installations, more competition is what will bring the cost down. And we saw this very clearly in Denmark, where we, for a few years, had a working solar thermal market. And continued R&D is also part, but I think this is also run by having a real market. Because a real market, a mature market, and it results in this economy of scale with improved subcontractor networks and logistics. And that is what, like the invisible hand, pushed down the price of the installations. And for this, we have the help now of the idea of the European Commission that they want to push large-scale solar thermal projects. And the important thing is that the support and the idea of the countries is that we should have the same kind of development that wind and PV had. That not just a small subsidy that makes a few installations, but the idea, how many installations do we need to get a mature market where the prices are pushed down so that it can outcompete the fossil fuel? And this can be calculated with data from IRENA, for example, that shows that the price decreases with every new volume on the market. And when you know how big volume you want on the market to have a working market, you can then dimension the support schemes to create that kind of market, just like what happened with the PV market. Because the PV is still a very complicated technology, while solar thermal is basically steel and glass and some aluminum and some copper, and then we can produce all the heat that the city needs. And we can store the heat from summer to winter as well. So I think that was my last one. Yes, thank you.
Perfect.
Yeah, thank you. Thank you so much. Also the presenters. We are now live in our session. As you know, this before was recorded from Monday. Yeah, good morning. My name is Christoph Brunner. I'm from AINTEC from Austria, and I'm happy to moderate now. And you have this possibility to use the Q&A session here to put your questions in the Q&A part. And at the moment, we do not have some new ones, but let's start with some questions. And I want to start with Joachim. Thank you so much for your presentation. Joachim, you spoke about this large-scale solar and it's also about storage. Considering now this mismatch, is it okay? You have to use the solar energy in summer, but of course there's a mismatch between the demand and the energy what comes from the sun. So maybe you can tell us a little bit more about this seasonal energy storage. Which kind of technologies do we have here, and what you consider as best technology, maybe in combination with solar thermal?
Yes. We are in different projects, both with pit storages and with boreholes, and also with large unpressurized tanks, which is the go-to when it comes to solar thermal in large fields. But I think that the pit storages have an advantage that you actually can install them in most cities. And I think for our solar thermal business, we have this challenge of actually communicating what we are doing. And the pit storages is an excellent opportunity to show how we can store heat from summer to winter. And that lights up a light when you talk to people. And it's even so that it often takes a lot of long time before people actually understand that we are doing solar thermal. They misinterpret and think that we are producing electricity no matter how many times you tell them. But by starting to talk about the pit storage and the large solar thermal storage in water, that brings their minds on the right direction, and they understand that we do hot water. So you save a lot of time when you introduce solar thermal by start talking about the pit storages. Mm-hmm. And what we showed in our research of Sweden was that most of the Swedish district heating networks, they had space and ground conditions to build the pit storages. Mm-hmm. Because if you take boreholes, for example, it's very much depending on what kind of ground you have. It takes a long time to really find out if it's good or not. So I would really recommend us in the solar thermal business to talk more about the pit storages, and because that. Yeah. But this said, I must come back to this, that the heat is most expensive in summer for most of those small district heating networks around in Europe. As long as you don't have waste combustion, the heat is most expensive in summer. And it's partly because what I told about that they use more expensive fuel, but it's also because the boiler runs on a lower capacity, and then you have a lower efficiency.
Yeah, exactly. Yeah.
So stop burning in summer should be also a parallel message.
Okay, super. Thank you. Thank you so much, Joachim. Yeah, there are two questions here. The PDFs, the presentations are available after the webinar, yes. And there's one question regarding the double ticket, 2 conferences costs. What will the double ticket cost? Robert, I don't know if you can answer this question in the chat directly.
To be honest, I'm not really sure about the price. It will be probably, to my understanding, it will be just a ticket of the one event, and you have access to the other event as well. That's the idea, but I'm not sure whether it's the price of the more expensive event or the price of the less expensive event. I would assume that it's the more expensive price, but it's not significantly more than the more expensive event among the two. I guess that's likely what will happen.
Yeah, good. Okay, maybe you can get directly in contact here to this question. Magdalena, thank you also for your presentation. I want to combine here a little bit some answer other questions here. First, there's one question regarding concentrating solar thermal energy for district cooling. Is this something what can be used? And the second question I want to combine here is the concentrating collectors a good technology for regions like Germany? And why do we need these concentrating solar collectors for solar district heating anyhow? Is it not more to reduce the energy or the temperature in the district heating systems and not to increase it? So maybe you can give us here an answer.
Yes, I will start with the second point. Concentrating solar thermal for district heating can make sense if the district heating has higher supply temperatures. So we have in Germany or also in Europe many existing district heating networks, for example, in cities where maybe industry is connected, which needs higher temperatures, or the systems are running on higher temperatures because it's built many years before where it was usual to use higher temperatures. And it's not so easy to lower these temperatures in existing district heating. And that's why it makes sense to include or to consider at least to use solar, so the concentrating solar thermal to directly supply the higher temperatures. For the part with district cooling, I guess there are people here who can better answer the question because we are not focused on district cooling. Is maybe Joachim or Robert?
You maybe.
Well,
no, not district cooling. No, sorry.
Robert,
can you answer, Joachim?
Well, we find this competition with compressor cooling quite daunting. So I don't really see large-scale solar thermal running district cooling. But we should also remember that today we get all the electricity for those compressor systems from China. And this is also a big risk in the global energy system that we are so depending on one country for doing this transition. So, but from a financial perspective, I don't really see large-scale solar thermal powering solar cooling unless there are special conditions where you have some joint applications.
Okay, great, super. Yeah, maybe some general questions anyhow. And there's always, let's say, a discussion between why should I use a large-scale solar thermal system if I can install a PV and in combination a heat pump system. I don't know who wants to answer this question. Comment on that.
Well, I think this is something we get quite often, that but then often people forget about the cost of the heat pump. And this comes down to economy. What is cheapest? If it's cheapest to build, and if there's place, the solar thermal takes like a third of the, or a fourth of the space of a PV field. This also translates to CO2 emissions, that building a solar thermal field makes just a fraction of the emission compared to building a PV field and a heat pump. But it comes down to the money.
Yeah, okay.
And
Maybe
solar thermal is cheapest.
Yeah, okay.
maybe one addition on this. It's not only the investment costs with PV and heat pump. It's also possible. The heat pump, of course, needs also electricity in winter the most. And you don't know how the electricity prices will develop in the next year. So there's a risk of higher prices. And so it's you need a lot of assumptions about the electricity prices to consider it in long term.
Okay, great.
But I would say that for those fourth generation networks running on like 55, 60 degrees centigrade, maybe the heat pumps can compete. But if we want to store heat in pit storages at 95 and we want to be able to increase the temperature, then solar thermals have definitely a big advantage. And there we are talking about the huge number of district heating networks already built compared to the very small number of new district heating networks with lower temperature.
Yeah, okay, yeah. Great, super. Yeah, and maybe one last question, because we are anyhow a little bit over time already. To increase, let's say, this solar thermal technology for district heating system, the numbers, which framework need? What do we need to from policy or from other parts to increase this number? Who can give the answer?
I think that the policies has been quite different to what it was with PV and wind, where there was a political will to actually make those sectors work. That has never been the intention on the support for solar thermal. The solar thermal support has been, okay, let's put 45% subsidy or 50% subsidy and see what happens. I think if the policy instead took the approach that, okay, we want to build 1 million, 5 million, 10 million square meters of solar collectors, how should the support system look to create this? We would have a different debate and the support systems would look differently. I think the heat auctions setup is very good, that you have a certain amount of money, you spend that for building, and you don't care really about what the cost will be because you are creating a market. And by doing this, you get the cost down, and for every heat auction, you will get more for your money. And then in PV, you called it grid parity. I'm not sure what we should call it, but it's something like solar thermal outcompeting everything.
Maybe one particular comment for the case in Germany. I think, particularly when we're looking to concentrating collectors, there are not, let's say, many options available around the world or in some countries, in particular in central countries, but in Germany, there's actually none. And that's something where it's also the question is, does it actually work in this kind of country? We haven't seen in other countries, but it really makes a difference to have a kind of reference project or several reference projects that really make people believe maybe the combination of flat plate and concentrating collectors makes a lot of sense. And we have faced that this is something which is a big hurdle to overcome because we're a lot of skepticism here. And the message that is working in other Central European countries is obviously not enough. So give the opportunity for reference projects as well to show the technology is actually working and is providing as expected, as calculated, is a very important first step, in particular for concentrating collectors.
Okay, yeah, good, super, thank you. And there's now really the last question what we have just popped up in the chat. What about the use of technologies like absorption chillers, which need heat to drive thermal compression cycles to make chilled water? Is there any quick answer on
when
this?
we've done the numbers, we didn't get it to sum up compared to a compressor cooling.
Okay.
Exactly.
Yeah. Okay, great, super. Yeah.
But when it comes to concentrators, everyone is welcome here to Härnösand to see our 700 kilowatt district heating. We are selling the heat every day, you know, so we can prove that it's working, or to go to Bari or to Carlsberg to see the solar concentrators in operation. So I think it's a proven technology, just to have the volumes and rollout.
Great, super. Thank you so much to all three of you for your presentations, for your answers. Yeah, I'm looking forward to see all participants also at the conferences which has been presented. And now I hand over to Ellen. She will make the last sentence, last comments. Thank you so much.
Thank you very much, Christoph, for your moderation, and thank you to the speakers and to the audience for your lively questions. To wrap things up, we have recorded today's session, and we will make the recording available to you on the ICES YouTube channel and also on the IEA SHC Solar Academy homepage. The same also goes for the presentations you have seen. They will be made available so you can download them. To all ICES members on the call today, I would just like to remind you that you have unlimited access to all recordings of past webinars in the ICES members area. And with that, thank you very much for joining us on the call today. You can stay in touch, of course, with both the IEA SHC and with ICES on different social media platforms. If you have any questions, please reach out to us at publicrelations.ices.org. And we are very much looking forward to welcoming you to EuroSun and SolarPACES this September. And we're also looking forward to seeing you on the next webinar. So bye, everybody. And thank you for coming.
Thank you. Bye-bye.
Bye.